You know
He's bigger. One of your birds who just forgot to wake up today.
Okay. So we're moving on to cellular respiration part 2, where we'll talk about pyruvate, kind of like a pyruvate conversion into acetyl-CoA, and then tackling the Krebs cycle. And then tomorrow you'll have a quiz on the Krebs cycle. And I don't know the figure offhand. I did list in Google Classrooms, but it's just like in the book. Okay, so you got to know. You don't need to know enzymes. You just got to know the molecules that go through the Krebs. So we just finished up glycolysis, a 10-reaction process where we're converting glucose into 2 pyruvate molecules at the very end. It produces 4 ATP and 2 NADH, but remember it consumes 2, so your net overall is 2 molecules of ATP and 2 molecules of NADH. And where does this happen inside the cell?
Cytoplasm.
In the cytoplasm or the cytosol, okay?
So it is cytosol?
Well, cytoplasm is what I'm looking for. But yesterday you mentioned cytosol, so I'm like, okay. So the first half of glycolysis, because you have to burn 2 ATP, is an energonic, but then because you generate 4, it's exergonic. So the first half is ender and the second half is exer. So stage 2 is pyruvate oxidation, where we're going to take pyruvate and we're going to convert it into a molecule of carbon dioxide and a 2-carbon molecule called acetyl-CoA, because pyruvate has 3 carbons in it. Okay, and we're just going to cleave one off. So here's 1 carbon, and then we're left with a 2-carbon molecule, and it kind of gets shuttled into the mitochondria. So after pyruvate's converted into acetyl-CoA, acetyl-CoA escorts it, if you will, to the mitochondria, where we'll hit the Krebs cycle. So we'll look at the oxidation of pyruvate. It's oxidized to produce a CO2 molecule and a 2-carbon molecule called acetyl-CoA. Electrons are being transferred again, so we are producing an electron carrier from NAD plus to NADH. And then what's happening is that pyruvate will be oxidized through decarboxylation. Anytime you cleave off a carbon and produce carbon dioxide, we call it decarboxylation. And so now we have an acetyl-CoA group. So here's the pyruvate oxidation. Pyruvate, we cleave off the carbon. And look, it's got 2 oxygens bonded to it, so there's my carbon dioxide. We generate an electron carrier. It is now coenzyme A, or acetyl-CoA. So this gets shuttled or escorted into the mitochondria, where it's going to get into the matrix and the inner membranes of it for the Krebs cycle eventually. So the acetyl group attaches to the coenzyme A, producing your acetyl-CoA. We're generating that electron carrier. It's carried out by a multi-enzyme complex, which means you have a bunch of enzymes lined up in a series, and they carry out multiple processes. So here's this formula equation. You have pyruvate, NAD plus the coenzyme A, and at the end of pyruvate oxidation, you get acetyl-CoA, NADH, carbon dioxide, and a proton. So, yeah. Step 3 is the Krebs cycle. So we're going to take this acetyl-CoA, which is that 2-carbon molecule, and it's going to be oxidized in a series of 9 reactions in the matrix of the mitochondria. You need to know that the Krebs cycle happens in the matrix of the mitochondria. Pretty sure that is a multiple choice question. And I will get a quizzes up for you, hopefully today during my prep. So focusing on the Krebs cycle. So the Krebs cycle, yes.
H plus, that sign literally just stands for a proton.
Yes.
Because it's positive, so it wouldn't be an electron. Like it'd be hydrogen.
But the electron's being stripped from it.
That's what I mean. So, so there's no electrons.
Right, it's just a proton. Yeah.
Okay.
So you can break down the Krebs cycle into 3 segments, where the first segment is you're going to produce a citrate molecule. Then the second segment, segment B, is what they call it. Citrate gets rearranged, and then decarboxylation, which means what?
Stripping of a carbon.
Carbon, yep. And what are you going to make?
The S, something, CO.
No, CO2.
Yeah.
Carbon dioxide. So decarboxylation means you're going to make a molecule of carbon dioxide. So then it's going to go through a series of 5 steps. We will make some energy carriers as well as a little bit of ATP. And then the third stage is this regeneration of oxyl acetate, where we're going to generate some more electron carriers. So not a lot of ATP, but a whole bunch of electron carriers, which will be used in the ETC. So pyruvate gets converted into acetyl-CoA, and then it enters the Krebs cycle. And so we're going to take this 2-carbon molecule and bind it to a 4-carbon molecule. Formin.
Whoa.
Is that you?
That was my iPad.
Okay.
No, I'm pretty sure.
Formin citrate.
Oh, no,
Okay?
oh, no,
It's me.
Oh, yeah. That scared the hell out of me.
Yeah.
I have no idea what this is.
First time I jumped a little bit.
Oh, I jumped a wee bit.
Okay, I honestly don't know what it is.
It's just a sound effect from when you click the thing.
I forgot I put that on. Okay, sorry. I muted it. All right, so citrate gets rearranged a couple times. Whoa, I go from 6 to 5. Decarboxylation is going to happen there. Okay. We're going to cleave off another. So there's another molecule of CO2. Then it gets rearranged several times, and the whole process starts itself. This happens twice for each molecule of acetyl-CoA that enters it, because we have 2 molecules of pyruvate at the end of glycolysis. So this happens twice.
How does it go from the 3 and 2? It would be 5, and then
Go
all
back.
of a sudden it's just 6.
Where are you?
Top.
Top.
3 and 2.
We cleave off.
Yeah, but then all of a sudden it's 6.
Now 2 plus 4.
Oh, flip 4 going over.
Yep, so it binds to this
Oh,
molecule.
exactly.
And you'll learn what this molecule is in a second. This is just a simplified. Okay, now I showed you the carbons. Now I'm going to show you the electron carriers, so lots of reduction. So when we cleave off the carbon up here, we generate an electron carrier. And it forms citrate. And it goes through some more. Well, we cleaved off, so CO2 and an electron carrier. Then it gets cleaved off again. Another carbon dioxide molecule and an electron carrier. And it goes through some rearrangement, where this is where we generate the ATP at the bottom. So on your quiz, you'll see a little explosion. And then it gets rearranged, and we have another energy carrier. This is the new player to the game, FADH. Okay, so it's a lower energy carrier of electrons. It's not quite as high as NADH, but it can still carry electrons. And then one more NADH for this rearrangement at the top there. So how many NADHs do we make from going once through the Krebs cycle?
4.
4. Okay, but now you got to remember, there's 2 molecules of acetyl-CoA, so 8. And then 1 molecule of FADH, but take that times 2, you get 2. Okay, so now what I'm going to do is I'm going to walk you through all the reactions. Okay, so the first reaction is called the condensation, where we're going to take acetyl-CoA and combine it to oxyl acetate to form citrate. Okay, and so your product is citrate. Then reactions 2 and 3 are called isomerizations, which means that you're just going to reposition hydroxyl group, and you're going to get isocitrate. I have a diagram at the very end. So, reactions 4 is the first oxidation, where you cleave off a carbon and generate CO2 NADH, and it's called alpha ketoglutarate. So now we have a 5-carbon molecule. Then the second oxidation goes from 5 carbon to 4 carbon, is called succinyl-CoA. Reaction 6 is a substrate level phosphorylation, which means you're going to generate some energy. So in this case, ATP. And then the resultant 4-carbon molecule is called succinate. Then the third oxidation, you go from succinate to fumarate, and you generate some more electron carriers, in this case the FADH. And your ending result is that fumarate. And then 8 and 9 is the regeneration of oxyl acetate, so it can continue the cycle of Krebs, because oxyl acetate will bind to that acetyl-CoA to form citrate. So water is added to form malate. Malate's oxidized at the spelling error to form oxyl acetate and an electron carrier. So here's what the Krebs cycle looks like summarized. Acetyl-CoA, oxyl acetate, citric or citrate. This says citric acid. That's fine. Then rearrangement, isomerization reaction turns into isocitric acid or isocitrate. We cleave off a carbon and we generate an electron carrier. Turns into alpha glutarate. I should have picked a different diagram. So we go from 6 carbon, 5 carbon, goes through another cleaving of carbons, okay, to turn into succinyl-CoA. This is where we get our first energy molecule, ADP to ATP, so substrate phosphorylation turns into succinate. More energy carrier, fumarate, malate with some water, and then another energy carrier. So we go from 4C, 4C, this all stays 4C. So the ones that you need to know are the ones that are bolded here. You got to know your energy carriers. Okay, so I think this is a gray box. I don't know what color FADH is. And if you see blue, it's water, right?
So we have to know like the bolded black words.
Bolded for sure, and then you got to know the byproducts.
Okay.
So, yeah.
What about the acetyl-CoA?
I don't remember offhand. Actually, I can think of it. You need to know the acetyl-CoA.
So basically, just everything on here.
So no,
Without the enzymes, you don't need to. You don't need. Yeah. So this diagram, everything, but on your diagram, you'll see enzymes listed. So for example, after isocitrate or isocitric acid, but on here it says isocitrate, it goes through an enzyme, isocitrate dehydrogenase. So look towards the enzymes to help you remember the names. There are no abbreviations for this one. Spelling doesn't count, but you'll do your best, right?
We'll have them all memorized.
Okay, now at the end of Krebs cycle, we have broken every bond in glucose, okay? Glucose is entirely consumed. We've taken a 6-carbon molecule. Every time we've cleaved, we've created either, ATP or energy, ATP or electron carriers. So far from this entire process, we have generated 4 ATP molecules, 2 from glycolysis, 2 from the Krebs because it goes through twice. We've generated 12 electron carriers, 10 NADH and 2 FADHs. So these came from the Krebs cycle, and 8 of these came from the Krebs cycle, 2 from glycolysis.
So this is all just Krebs cycle, not the glycolysis.
8 from the Krebs, 2 from glycolysis. This is Krebs. Okay.
What do they call it, the Krebs cycle?
Well, first they called it the citric acid cycle, and then the person that discovered it, his last name was Krebs.
That's such a weird last name.
All right. So basically, we're generating electron carriers. So there's the piggy bank holding those electrons for us, and a molecule of ATP, but it goes through twice. So these are the net results. All right, so why do the Krebs cycle? If the yield is only 2 ATP, how does the Krebs cycle, why did the Krebs cycle come about? It has everything to do with the electron carriers, because it makes a bunch of electron carriers. These electron carriers will move to the ET. Oh my gosh, Herman Norcross, why didn't you tell me to zoom in? You even listening to me? I hope so. Whoops.
You were.
I'm so sorry. I just got carried away with the Krebs.
We have a question. Are we having the quiz tomorrow on that one Krebs cycle you showed us?
It's the diagram in your book.
But you couldn't see it.
Yeah. Is it that same diagram?
It doesn't look like that, but it is similar.
Ooh.
Here, let me pull up the book.
Okay.
You could probably just pull up the thing that you showed us. And they could just take a picture of it. But I did.
Oh, Rube, is that why you took a picture? I'm like, why are you snapping a picture of me? I was like,
Yeah, I did.
not me.
It's your Spanish. So everyone come get pulled work at work.
What? I'm not gonna do some practice. Oh yeah. And I want to take a shower too.
Danica, do you maybe want to just find someone else to work with you?
Because we need to start selling by 5.
Matt.
Well, here's the thing, Matt. You don't play a fall sport.
Yeah, Matt. Since you don't play a fall sport, will you please help Danica sell tumblers and split the pot?
We were gonna do it.
Hey, you still haven't brought me a tumbler.
We were gonna do it,
I was
Matt.
just telling Jaden how I've already worked like 6 times.
Matt,
But fine,
I was
I will.
gonna do
What?
it,
What
but I
time?
had
5 o'clock.
practice.
What?
I was gonna do it, but I had practice.
You can
5
come
o'clock.
after.
But I
All
have to
right.
leave for pep time,
Here's the
obviously.
Krebs cycle diagram. This is what your quiz will look like. And obviously, I'm just gonna white out bolded items as well as things that are created
The
from
random.
it.
So we just don't have to
CO2.
Right. So acetyl-CoA binds to oxaloacetate to form citrate. Citrate gets rearranged to isocitrate. Now look, here's that enzyme, isocitrate.
Do we have to know the number of carbon?
You just gotta
Wait,
write
so
CO2.
those things are gonna be on there for us?
Yeah. I can't. I'm trying. I'm
Let's take this quiz today.
okay. Sure,
I
you can
don't
take
know
it today,
about
mini Matt.
Actually,
Well,
Pretty much
realistically, all the answers
But then
are on
we
there.
cleave off a
Besides the
CO2
last
energy
oxide.
carrier, alpha keto glutarate. Oh my gosh, guys, alpha keto glutarate, right there. Okay, it's succinyl. I don't know what I did down here at the bottom. Oh, you got to know GTP. Yeah. So
Wait, GTP? That was ATP.
yeah, but down here's ATP. I gotta scroll down. Told you guys, it's the diagram of the book. Just look at the book. So then we have succinate. Oh my gosh, succinate dehydrogenase. Fumarate. I mean, I can't.
Oh, that one's got an
Yeah,
S
that
instead of
can't
a
make
T.
this
How am I supposed to
any
do
more
that?
challenging, right?
that's pretty difficult. Fumarized.
Okay.
Yeah, it's
I'm definitely good at it.
It's not the same. I don't know if I can do that one.
Okay, going back to the value of the Krebs cycle. It's all about electron carriers. And how do we know that? Well, every time that every time an electron is picked up by an electron carrier, a proton is being released. And where do these protons go? Well, eventually they're going to build up a proton gradient in the mitochondria, and it's going to go flow through this ATP synthase, which is kind of like a turbine, if you will. So high concentration here flows from high to low, and as they go through, this thing spins, literally spins. And ADP gets smacked. What just happened? Ooh. Why did I do that?
Ray must be hacking us.
Seriously, you took me back like 3 slides. I'm gonna go through all this.
There's the turbine.
ADP gets smacked together with a phosphate to form your ATP molecule. But we're not done yet, so that's tomorrow.
Oh,
To be continued, right? Okay, so you should be working on your guided notes. Herman Norcross, did you find the review guide and the guided notes in a green folder?
Yeah.
Okay.
So, Miss Erickson.
So the rest of the time is yours to work on that, ask questions, study for your Krebs cycle quiz tomorrow. Yeah. So.
Do the base or-
Hannah. I will show up to work. Why
Miss Erickson.
on earth
So
would I be
the
there?